In Chapter 4, we're going to start talking about some properties of exponents. And the first section deals with what happens when the exponent's 0 and what happens when the exponent's negative. So those are the first two properties we're going to talk about. Now, we've talked a little bit about exponents in Chapter 1, so I want you to remember a couple of things that I told you back in Chapter 1. First of all, let's talk about the parts of an exponent and a base. The exponent tells you how many times to use the base as a factor. And so when we're looking at 2 to the third power, one part is called the base, and so that's going to be the 2. That's our base. And another part is called the exponent, and 3 is our exponent. So just knowing when I say the words base versus when I say the word exponent, I would want you to know what I'm referring to. So again, 2 to the third power means that 2 is the base and 3 is the exponent. And of course, I'm sure you all remember this, but what that means is you're going to take 2 times 2 times 2. Again, it's saying how many times should that base be used as a factor. And a factor is just something that's being multiplied together. You would call the individual things that are being multiplied together as factors. All right, so 2 times 2 times 2 is actually 8 if you wanted to evaluate what 2 to the third power is. But the important thing to know here is that 2 is the base and 3 is the exponent. All right, the second thing that we learned back in Chapter 1 was that the exponent is applied to the base only. And so that might seem obvious, but let's review what that means. So in this first example that I have here, negative 2 to the third power, the 3 is attached to the 2 only. And so this, remember, was like saying that you had a negative 1 times 2 times 2 times 2. So that 3, that exponent, is only attached to the 2. All right, so this in this case, you'd get a negative 8 because 2 times 2 times 2 is 8, and then you would be multiplying that by negative 1. In the middle example, though, we have parentheses around the negative 2. So in this case, we have negative 2 being taken to the third power. And so if you want the negative to be multiplied 3 times, it has to be in parentheses. Otherwise, only the base is raised to the third power. In this case, negative 2 is considered the base. So if we have negative 2 times negative 2, we get positive 4, and positive 4 times negative 2 gives us negative 8. And then finally, if we were trying to think about what was really happening with the last example, 2 times x to the third, first of all, let's talk about the fact that x is the base, 3 is the exponent, but the 2 that's in front is just considered a coefficient. So that's another vocabulary word hopefully we've talked about in the past, but if we haven't, the coefficient is a number in front of a variable. So our 2 is our coefficient. So again, the exponent of 3 is only attached to the x. And so in this case, if we're going to expand it out, it would be 2 times x times x times x. Only the x is going 3 times, not the 2. All right? All right, so that's just a couple things I wanted you to remember. It's super important that you understand what the exponent is attached to and what it's not attached to. All right, so let's talk about our first property. Our first property is what happens when 0 is an exponent. What do we do? Well, the property says any number or variable that has 0 as an exponent is always equal to 1. So that seems pretty easy, right? And it mostly is, but let's look at a couple examples here. So in A, it says 4 is being taken to the 0 power. And up above, it says anything taken to the 0 power is equal to 1. So this would mean 4 to the 0 power is 1. In B, because of the parentheses, we know that the negative 3 is being taken to the 0 power. And so that means the answer is 1. Anything, any number, any variable that's taken to the 0 power is a positive 1. In C, we have a decimal being taken to the 0 power, and that's okay. It says any number, even decimals, being taken to the 0 power are equal to 1. And I probably should have squeezed in another example. Let's squeeze in a second one. What if I took 1/2 to the 0 power? 1/2 to the 0 power is going to be equal to 1. Again, anything taken to the 0 power is equal to 1. In D, it says -3 taken to the 0 power. But remember, it's not really the negative that's being taken to the 0 power. That negative doesn't have parentheses around it. So this, again, is like a -1 times just the +3 to the 0 power. And so that's like a -1 times 1, because 3 to the 0 power is 1. And the final answer is just -1 instead of +1. So the only thing really being taken to the 0 problem in example D, remember, the only thing attached to that exponent of 0 is that 3. So this is the only part that becomes 1, and then the negative gets attached to it at the end. So be careful with that. So in the top row, we had all numbers. In the bottom row, we threw in some variables. So even though we have a variable in E through H, we know that variables are standing in for numbers, so they work the same as numbers. So even a variable that's raised to the 0 power is going to be equal to 1. So x to the 0 power is going to be equal to 1. In F, that entire parenthesis is being raised to the 0 power. So I don't know what x, y, and z are. They can be any numbers. Remember that an x, a y, and a z right next to each other are indicating multiplication. So I don't know which 3 numbers we're multiplying, but it doesn't matter. Whatever we multiply together is going to be raised to the 0 power. So the final answer is going to be 1. We could have put 1,000,000 inside of a set of parentheses and raised it to the 0 power, and the answer is still going to be 1. Now G and H get a little bit trickier because, again, you always have to remember that top number 2 that I said. The exponent is applied to the base only, so you have to always ask yourself, what is the base? And so if I look at G, that 0 is attached to the x only. So again, the only thing that is becoming 1 is x to the 0 power. So this is like 3 times a 1, which is just 3. So be real careful deciding what's being taken to the 0 power. And so in H, again, the only thing being taken to the 0 power is this x. So this is the only thing becoming a 1. And so this problem is really like 3 times 1 times y. And 3 times 1 is 3, and of course 3 times y is just 3y. So when you evaluate exponents, make sure to apply them only to their bases. All right, so that's the first rule. That's that first property that we've learned here, is that any number or any variable that's taken to the 0 power is going to be equal to a +1. But we can see it's not always as easy as that sounds. If you look at D, G, and H in this example, you can see sometimes you have to think about it a little. All right, example 2 is going to be about negative exponents. And I have quite a few examples here because negative exponents can be a little trickier than an exponent of 0. So negative exponents say that if you have a negative exponent in the numerator, it gets moved to the denominator and it becomes a positive exponent. Negative exponents in the denominator get moved to the numerator and become positive exponents. And you might think, why? Why would we do that? Well, it's standard practice in math to state final answers with only positive exponents. So you're going to see that on most of your homework, that all final answers should have positive exponents only. It's just a rule in math, kind of like the same thing as all fractions should be reduced. We will also want to state all exponents as positive exponents. And so anytime you see a negative exponent, you've got to remember that it needs to be moved. All right, so in example 2a, that -2 is attached to that 9, so it needs to be moved. It's in a numerator. Remember that if you don't see a denominator, you really could stick it over an invisible 1. Any number that doesn't have a denominator really has an invisible 1 underneath it. So you could always think of it that way. So 9 to the -2nd power, that is really in a numerator. And so if it is in the numerator, it gets moved to the denominator. And so we're going to take this 9 and move it to a denominator so that the variable can become, so that the exponent can become positive. You never leave an empty numerator. If you have an empty numerator, you stick a placeholder of 1 up there. And if it's something that you can evaluate, like 9 to the 2nd power, we know what that is, right? That is, let me write it underneath. That is 1 over 9 to the 2nd power is just 81. Although I guess you are allowed to use calculators. I'm kind of remembering years when we weren't giving the kids calculators, and then if it was a really big number, I didn't make them expand it out. But you guys have calculators, so you can always take this a little farther if it's all numbers. You can take 9 squared down to 81. All right, in B, it says we have a negative exponent. Now be careful when you move a negative exponent. The only thing that changes is the sign on the exponent. So in B, we have negative 4 to the negative 2 power. Because of the negative exponent, we have to move it. And so again, it doesn't really have a denominator, so we're going to create a denominator and we're going to move it. When we move it, we do not change the 4 to a positive number. We leave the negative 4 to positive. The negative 4 stays negative. The only thing that changes is the exponent sign. So that's going to become a positive 2. And of course, again, you have an empty numerator, so stick a 1 up there. Negative 4 squared, just like we said up above, if we had a negative 4 squared, just like I had over here, we had negative 2 to the 3rd power. It really does mean negative 4 times negative 4. And so this becomes 1 over positive 16. All right, in the next one, this can be very tricky. We actually only have the 4 that's being moved, right? We have the 4 being attached to the negative 2. In my Marcelin class, I would always make them circle what was actually moving. And so what's actually moving is the 4 to the negative 2. That's got to get moved to the denominator, and the exponent becomes positive when it moves. So what did we leave upstairs up in the numerator? We left a negative, which again, a negative just sitting up there makes no sense. You'd have to stick a 1 in front of it. And so this is a negative 1 over a 4 squared, which is 16. So you could certainly write the answer like that. And I'm pretty sure I talked about it before. In an answer key, they're going to stick that negative. So I'm going to write an or here. They're going to stick that negative in front of the fraction bar. Anytime you have a negative anywhere in a fraction, it really just means the whole fraction's negative. So that's what they would write in an answer key. They'd write negative 1 over 16 with the negative in front of the fraction bar. All right, in D, we now have a negative exponent that's in the denominator. So if we look at our notes, it says if we have exponents in the denominator that are negative, they get moved to the numerator. So just the act of moving the exponent is what changes its sign. So you can move it up or you can move it down. So in D, what are we actually moving? We're moving this up. And so we end up getting 4 to the 3rd power. And remember, you're bringing it up next to a 1, so you could think of it as 1 times 4 to the negative 3rd power when you bring it up there. That's fine, but 1 times anything just is the number itself. And so 1 times 4 times 4 times 4, 4 to the 3rd power is 64. So 1 times 4 to the 3rd power is actually 1 times 64, or 64. Okay? So remember that negative exponents need to move because there's a standard practice in math that says you should always state final answers with positive exponents. And when they move, only the exponent changes signs. All right, let's do a couple with variables. So x to the negative 3rd, that needs to move, right? So there is no denominator, so that means there's like an invisible 1 down there. So again, you're taking that x to the negative 3rd and moving it down. And you're bringing it next to a 1. Well, that's okay. We're just going to leave an invisible 1 on top, and we're bringing x to the 3rd down next to the 1 that's already there, and it's changing its sign. It's becoming positive because it moved. Whereas in F, we're moving y to the negative 2 up. Again, the act of moving it changes its sign. So that's going to become a positive 2. So we're going to end up with y to the 2nd power. And because it moved, we didn't leave anything in the denominator. So the denominator can disappear because, again, it'll be an invisible 1. All right, in G, just the x to the negative 3rd is moving. So we're leaving the 2 up top, and we're bringing the x to the negative third down to the denominator, and it will change its sign. So again, you don't have to circle, right? You don't have to circle what's moving, but if you do, sometimes it helps you to leave the things that need to be left and to only move the things that should be moved. If you don't want to circle them, you certainly don't have to. All right, in H, the thing that's moving is the x to the negative third, and it is moving up. So we end up having the x to the negative third joining the 2, but turning its exponent positive. So a mistake I sometimes see is people move the thing with the exponent, but then forget to change its sign to a positive. So make sure if you move it, then you must change its sign. All right, in J, oops, no, not J. Let's go over down to, well, that's not C. I guess the numbering got messed up, but that's okay. In our C, our extra C here, the thing that's moving is just the C to the negative third power. So we'll leave 4b on top, and we will only move the C to the negative third, and by moving it, it turns positive. So you'll have several of these to do for homework tonight. And by the way, the homework is out of an old book because I liked the homework out of that book, so it'll look a little weird, but it's out of a textbook that we used to use. All right, in J, what has to move is n to the negative 5. That's going to move down. So m squared does not need to move because it already had a positive exponent. N to the negative 5 will move down, but it will become positive. Nothing was left in the numerator, so we stick a 1 up there. We would never leave an empty numerator. It means there's a 1 up there. All right? All right, 2 more. If we look at K, what needs to move down is x to the negative 3. What needs to move up is y to the negative 2, because both of them have negative exponents. So one needs to move down and one needs to move up. Notice I didn't circle the 2/3. The 2 and the 3 do not need to move, so we'll leave those alone. But the y needs to move up so it can become a positive 2, the exponent can, and then the x to the negative third needs to move down so the 3 can become positive. So some people get a little move happy and they start moving everything, which is why circling things sometimes helps. All right, finally in L, we threw in some exponents of 0 just to tie in example 1 with example 2. So that might happen in your homework. So the thing that's being raised to the 0 power is the x to the 0. So this whole thing is going to become a 1. 4 to the 0 power is also going to become a 1. That kind of looks weird. Let me make that look a little better. All right, so x to the 0 power is becoming 1. 4 to the 0 power is also becoming a 1. B to the negative 7th needs to move down, and C to the negative 4th needs to move up. So we've got a lot of stuff moving here. So maybe this helps you, maybe it doesn't with all this circling. For me, it kind of helps. So anything that becomes a 1, and sometimes instead of circling it and putting the 1 like that, let me erase some of this here, I just cross them off. It means they become a 1. So we could just cross them off also. That might be a little less busy. All right, we'll move to the B to the negative 7th down. We'll move the C to the negative 4th up. We know that the anything to the 0 power disappeared and became an invisible 1. And so at the top, we have a 3 that never moved. We have the C to the negative 4th that needs to move so that the exponent can become positive. We have the B to the negative 7th that needs to move down so the 7 can become positive. So that had both rules happening at the same time. And I know some of the problems tonight have the 0 property happening as well as the negative exponent property happening. All right. So if anything's taken to the 0 power, it turns to a 1. If anything has a negative exponent, it has to move so it can become positive. Make sure to follow the rule that if you realize that the exponent is only attached to its base, and so you shouldn't be moving things unnecessarily.